Okay, so here's what I do. For a log, there's basically a definition up there at the top. And this is read as log base b of a, which is written right there. And we can rewrite a logarithm as an exponential because they're inverses of each other. Just like, plus sign and a minus sign are inverses. Exponential equations and logarithmic equations are inverses. One undoes the other one. But what I do is instead of trying to memorize what goes where, as long as the log is on the left-hand side, and if it's not, then you can always flip-flop an equal sign, so it's no big deal. So if the log is on the left-hand side, what I do is I call it the circle method. And so we start with the little 3, and that becomes a big 3. And then using the circle method, it goes to pass the equal sign. So that 3 becomes the exponent. And now I'm crossing the equal sign up at the top, so equals, and then the one in the middle. That's how you take a log and rewrite it as an exponential. Those two things mean the same thing. It's just different ways of writing it. The log we use to help us figure out what the exponent is. So that's why it's an inverse. So like on the next one, using the circle method, what would that be?
2 to the 4th equals 16.
Yep, 2 to the 4th equals 16. And then this one, 5 to the 3rd equals 125. Don't let fractions and negatives and all that stuff scare you. It's done the same. For example, I'm going to skip to this one real quick. So that we would write that as 36 to the 1/2 equals 6. And think about that. Remember 36 to the 1/2 means what? It's not divided. Square root. And square root of 36 is 6. So that's what that means. But this is just what you would do to rewrite it. Okay, see, go ahead and rewrite the rest of those, just like we did using the circle method, or whatever method you want, but rewrite it as an exponential. And you don't have to change anything. You don't have to reduce anything. We're just rewriting it. There's really no work here. All of those in that box. All right, Cameron, give me this one.
All right, 10 to the 3rd equals 5.
Yep. We did that one. Jenna, let's do this one.
27 to the 2/3 equals 9.
Yep. Good. Justin, this one.
I got 9 over 2 equals 243.
9 to the 5 over 2 equals 243. Yes. Kendrick?
0 to -6.
Remember, it's like this. So which one do we start with?
10.
10.
10 -6 equals 0.0000.
Yeah. That. We good? Tyler, this one?
5 to the 1/2 equals the square root of 5.
And we know that. That's what we just talked about a minute ago. Let's see, what about this one, Donna?
4 to the 4
Uh-huh.
equals 4. I don't know what's it called.
Cubed root?
Yeah, of 4.
4 times cubed root of 4. Absolutely right. What about this one, Isella?
That's 3 to the 1/5 equals 3 to the 1/4.
Kind of makes sense. Amaria, this one?
4 to the -2 equals 1/16.
Excellent. Shelby?
5 to the -3 equals 1/125.
Yep. Jose?
5 to the 1st equals 5.
Yep. And then this one, I'll do it. 6 to the 1/3 equals cubed root of 6. All right, good deal. Questions? So this says, based on studying the examples, blah, blah, blah. I would just say, call that X. And I would just use the circle method. Let's say B to the X equals A. So now looking at these up here. So if B equals A, so if these two numbers are the same, which would be this one and this one, are the same. Look at these examples and find some that are like that. And what do you know about X? Yes. So it's kind of like a shortcut, but I personally just write it every time because then I don't have to worry about memorizing things. But yeah, if you do notice A and B, the base and the number right next to it are the same, then yeah, X is going to have to equal 1. If B is less than A, so looking at these two, if B is less than A, we want to see what we can figure out about X. So B is less than A. X is what? Not necessarily. This is an example of one. B is less than A. It's what? So
B is greater than
B is less than A. It's positive. That's true. Yes. It's kind of hard to come up with these because I'm looking for a specific thing, and you don't know what I'm looking for. It's X is going to be greater than 1. So X is greater than 1. So that answer for that one we were looking at just a second ago was 5 over 2. that is definitely greater than 1. So what do you suppose is going to happen if b is greater than a? It's less than 1, yeah. Again, I'm not too crazy about the having to know that, looking at that. I don't feel like you have to, because you can figure it out every time really quickly. So there's no reason to memorize all that stuff. Now, if you are a person that likes facts and wants to memorize those things, that's cool. I personally like to memorize as little as possible and figure out ways to figure it out every time. Okay, so here's where our calculator is going to come in handy. When we have a log that has a base 10, it's called a common logarithm. The one that's on your calculator, this is log, that's a common logarithm. Or if you're at home, on your Desmos calculator, that is a common logarithm. Or even if you're using your phone, you turn it sideways. It's a common logarithm. So, it's understood to have a base of 10. So like this log, it says log 5. That means log base 10 of 5. It's just not going to say that because, as we know, mathematicians are inherently lazy. And we like to simplify things. And we like things as simple as possible. We don't want a bunch of extra stuff. So if it's a common log, if it doesn't have a number there, we assume it's a 10. It's an understood 10. So all you have to do here is hit log 5 on your calculator. And we